Welcome. This question says a sample of ideal gas contains 4e to the 9 gas particles in 8 cubic meters. Each particle has a mass of 9 micrograms. The average speed of the gas particles is 4 centimeters per second, and then what is the resulting gas pressure? So let's visualize it. Here's our volume. And let's make a list. So the number of particles equals 4 times 10 to the 9. That's what it means. 4 times 10 to the 9 particles. And then the volume, of course, is 8 meters cubed. And then the mass. Well, the mass is given as 9 micrograms, which equals 9 times 10 to the minus 6 grams, which equals 9 times 10 to the minus 9 kilograms. And we have to be in kilograms for our equations to work. And then our speed. So I've got to be careful. There's two V's here. There's big V, which is volume. And if you like, there's curly little v, which is velocity. And that's 4 centimeters per second, which equals 4 times 10 to the minus 2 meters per second. Again, doing my conversion to get into standard SI units. And then it wants to know what the resulting gas pressure is. Fair enough, we have a number of things we had to convert to get them into the right units. That's the way it goes. And then the equation that we're going to use is P is equal to 2/3 the number of gas particles over the volume times the kinetic energy, which is a half mv squared. And just so you realize, so this is a kind of weird equation where they've messed with it. The actual thing they got out of the math was 1/3 n over v times m little v squared. And then somebody came along and said, you know, m times little v squared is a bit like kinetic energy, but kinetic energy is a half times m times little v squared. So they said, oh, well, that's fine. We'll just put that down as kinetic energy, and we'll put a factor of 2 over here to compensate for the half. So it's a kind of like it's an educational equation in that it's got a bit of insight and designed into it. But it's just an equation. So we say, well, P, the pressure, is equal to 2/3, and then this is going to be 4 times 10 to the 9. And that's going to be over 8. And then we're going to have 1/2. And then we're going to have 9 times 10 to the minus 9. And then we're going to have 4 times 10 to the minus 2. But that last whole thing has to be squared. So P is equal to 2/3. 4 times 10 to the 9 over 8, and then 1/2, and then 9 times 10 to the minus 9, and then we're going to do this bit. Well, to square it, the 4 goes to 16, and this goes to times 10 to the minus 4. And the rest is calculator work, isn't it? So I come along and I say, okay, fair enough. It's 2 times 4 second EE to the plus 9, enter, times 9 second EE to the minus 9, enter, times 16 second EE to the minus 4, enter, divided by 3, enter, divided by 8, enter, divided by 2, enter. And that's me. I don't like to use a lot of parentheses. I like to just work it out step by step. And so if I look here, this gets me 0.0024, and of course, I'm working in SI units, so this would be Pascal. So pressure is equal to 2.4 times 10 to the minus 10 to the minus 3 Pascal. Very small pressure. I've not used realistic numbers. I wanted to just play with the numbers. And this is a great opportunity. So from a teacher's point of view, this is a great opportunity because I can throw a whole bunch of different inappropriate units at you. And I could also, for example, I could give you a different shape. I could say a sphere of material contains this many particles. So there's a whole bunch of things I can do just to see if you know the equation and then push you a little bit on your conversions. So there we have it.